Okay, so we're going to do Venn diagrams is our last chapter of problem solving. And Venn diagrams is something that you've done in math probably before. We actually did like an activity, if you remember at the beginning of the semester, we did a Venn diagram of like likes and differences between us when we were first meeting. So it was kind of like a little intro. It's really just like a way to spatially organize your information. So we're going to go through different types of Venn diagrams today to see how we set things up. And then what you'll notice is that most of the word problems that we do, they're all going to really look like the same Venn diagram. So that's good. So we are back to writing our own explanations and following all that format as well. Okay, so let's go ahead and look at a few different examples of Venn diagrams, what they could look like, and then we'll see a couple of the examples that you can expect from this class. So here is an example where all the categories are different. So if everything is different, that means that you don't have anything in common. So the point of a Venn diagram is to see where like you have this overlapping commonality. If you have 3 different categories, there should be no overlapping. They're completely different. So we symbolize each category by like a circle. So these 3 categories would be like dog, cow, horse. They have nothing in common, so they just kind of all 3 stand alone. Okay? Example 2 is the first category is related to the second, and the second category is related to the third. So if we take a look at the categories here, we have rose, flower, plant. So thinking about that, we know that you want to think about like what is your biggest category? Okay, so between rose, flower, and plant, aren't all of these things plants? So plant is like our biggest category. That's where we want to start. So I'm just going to draw one big oval and start there with plants. So flowers are definitely plants. So all types of flowers, no matter what type you're talking about, is a plant. So you would want to put all of the flowers inside of the plants. And then finally, rose is like a specific type of flower, which is also a specific type of plant. So that would fall inside of the flower category, but notice that the rose is also the plant. Like everything is related here to each other. Bless you. Example 3. 2 categories are unrelated, but completely related to the third category. So sophomore, senior, student. So thinking about like the big category there, that would be student. Okay, so that's where we would want to start with our big category. And then we have these other 2 subcategories, which are sophomores and seniors. And both of those categories are students, so they should be within that big oval, but sophomores and seniors don't relate to each other. So those would be separate categories within our large category of students. So example 4 is what you can expect the most of with the problems that we do. So these are 2 categories that are partially related, and they're completely related to the third category. So the difference between example 3 and example 4 is that our 2 subcategories kind of relate to each other. There is some overlap that happens there. So there's sisters, mothers, and women. So the large category would be women. And then we have these 2 subcategories, which are like sisters and mothers. And so what you do with that, if they have some things in common, is you just overlap them. So this could be sisters, and this could be mothers. And then thinking about this little piece on the in-between, everything that's within that highlighted yellow section is a person that is both a sister and a mother, and then obviously a woman. Okay, so this would be, like, I would fall into this category. I have a sister and I'm a mother. someone that just, like my daughter, she's only a sister, okay? So she would fall into just this piece here where I would be in the yellow section, okay? So this is what we want to think about, is how do these things relate and what doesn't really fit into maybe a certain category. Okay, so actually on here, I changed these notes, but I had these old ones copied, so I think we're going to skip this entire page. And then, I think we just want to go to, oh, we don't have this at all. Oh, good, 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 good. Oh, it is there. Okay, hang on. Now that we crossed out that entire page, I just noticed that the bottom problem is the one we need. So that's okay, we'll just go back. We're going to do junior prom. Okay, so I crossed it off, but no big deal. Alright, so this is an example of what you can expect from problem solving with Venn diagrams. So the strategy would be Venn diagrams. We're back to like writing our final answer, showing our work, writing our explanation. I'm not going to write an explanation today just to save time, so you have time to finish the problem for today. So, junior prom. There are 120 juniors in the current class. Of those, 66 are going to the junior prom. The same number of juniors, 66, are going out to dinner that evening, including 48 of those not going to prom. How many juniors are neither going to prom nor going out to dinner? So there's this idea of this neither category where it just doesn't fit into anything. So what I'm thinking to myself right now is the different types of categories that I need. I noticed that you're talking about junior prom and that there's these two events that are going on. There's prom and then there's dinner. And so those would be like my subcategories. But then there's people that are going to fall into neither. Okay, so that's like my big category, is like nothing happens there. So I'm just going to put a box here and label that with neither. This represents the people that just are not going to do either one of these things. And then the two categories that I have are dinner and prom. And some people are just going to go to dinner, some people are just going to go to prom, but there are people that are going to do both. So that's where I want to see those overlapping circles. So I'm going to draw two circles within this box. And I'm going to label them, one with prom and one with dinner. And so what I like to do is kind of, if you highlight the two circles separately, so choose two different colors, here we can see that pink circle is going to represent prom, and then for me this green circle is going to represent dinner. And what I'll notice is that on the in-between, they kind of coexist, right? This is where that overlapping is. So within this overlap, that represents the people that are going to go to dinner and go to prom. So now I've set up my Venn diagram. Now I'm going to start putting all these numbers in. Okay, so I want to go back. It says that there's 128 or 120 juniors in the current class. So this is like the total number of people. I want to make sure that at the end, when I figure this out, that that total reaches 120, that everybody's been accounted for. It says that of those, 66 are going to the junior prom. So I'm just going to take some notes here. So 66 people are going to prom. The same number of juniors are going to go to dinner. Okay, so then dinner is also 66. It says here that including 48 people going to prom. So this number right here is really important. Okay, this is like your overlap. So that's where I'm going to start, because it says those 48 people are going to both dinner and prom. So I know that the number within here, the middle where they're overlapping, is 48. So I'm going to put 48 there. How many juniors are going to neither prom nor going to dinner? So I'm trying to figure out how many people don't fit into any of these categories. So let's think about how to do this. You start at the overlap and then you work your way out, okay? It told me that 66 people were going to prom, that 66 people were going to dinner. but I know that 48 of them are going to both. So what should I do with these numbers? What should I do with this 66 and 48? Subtract them, because wouldn't that tell me the people that are going to just prom or just dinner? So I'm going to subtract 48. Okay, that's going to give me 18. So that means that 18 people are just going to prom, because this 48 represented both. I can probably make this a little bit bigger. Okay, so that means that 18 has to go here. And the same scenario was true with dinner, right? 66 people were going to dinner, but 48 are doing both, so you would subtract, you would also get 18. So I want you to take a look here. Within this pink circle, you should be able to add that up and get to 66, okay? Because it said 66 people are going to prom. It says 66 people are going to dinner, so within this green circle, I should be able to add that up and get to 66. So now the question is, how many people are doing neither? So what should I do at this point? How many total people are there? 120, right? There's 120 total juniors. Okay, so what I'm going to do is I'm going to start taking away all of these people that are accounted for. So I can subtract 18 people that just go to prom. I can subtract 48 people that go to prom and dinner. I can subtract 18 people that just go to dinner. And when I do that, that's going to leave me with the total people that do neither one of these activities. And so when I subtract all that, I end up getting 36. So 36 people represent the neither. So that would go like outside in this box, right? Technically this box really isn't there. That's like people that just don't fit into those categories. So 36 would be my total answer. And really it should be like 36 people in this case. Now to write your explanation, you're going to talk about that you use the Venn diagram strategy. You're going to talk about how you created those overlapping categories, like how you actually drew the diagram, and then you're going to talk about the subtraction that you did. Okay, so you're always starting at the overlap and starting to subtract. So that's what we're going to keep in mind here. So let's keep going. Let's do one more example. Okay, so this one's called Music Survey. In a poll of 46 students. Okay, so right there, the very first thing they tell me is how many total students I have. At the end of this, I got to account for 46 people. 23 liked rap music, 24 liked rock, 19 liked country. Of all the students, 12 liked rap and country, 13 liked rap and rock, 14 liked country and rock. And of those students, 9 liked all 3 types of music. How many students did not like any of the types? Okay, so here's what I want you to do right now. I want you to try to imagine, I know there's a lot of information here, there's a lot of numbers. I want you to imagine, like, what is your Venn diagram supposed to look like? Like, how do you create these overlapping pieces? So I want you to try to draw that now. So there were 3 types of music: rap music, rock music, and country music. Okay, so it said, like, at the end, all of these started to relate to each other. So I need 3 circles that relate to each other. So I'm going to draw 3 circles where I have all of this overlapping. Okay, so this could be rap, rock, and country. And again, I'm going to, I didn't spell it right. I'm going to take a second. I'm just going to highlight everything so I can kind of see where everything overlaps and like what relates to each other. Okay, so before I highlight this next one, take a look here. So wrap, just on its own, this little section of my circle is only students that just like wrap. Do you see here that this overlapping here is students that like rap and rock? But the only one that really just likes the two goes right here at the top. Because what happens is when you highlight this country circle, now we can see that this little piece here in the very center represents all of them, right? All three of them intertwining. And that's where you have to start. And the same idea, I'm just going to put like a box around this to represent students that don't fit any of these categories, and that's going to be like my neither category. So it said within the problem that 9 students liked all 3 types. So where you see the innermost overlapping, that's where you begin, okay? So start here. Oh, you can't see that. There you go. Start here. Okay, so I'm going to put my 9 in the very center because 9 liked all 3. Okay, then I take a step out. So I've dealt with that information. Now I'm going to go right here. It says 14 liked country and rock. So I want you to find where those overlap. Country and rock. So are you looking at this like little almond shape here? But now total in the almond have to be 14. How many are already there? 9. So what do I do with those 2 numbers? Subtract them. You got to always keep subtracting. So I'm going to take 14 and I'm going to subtract 9. So really in that category is 5. Within that almond, I should be able to see 14 people that overlap in both rock and country. Okay, so now I take a step out again. 13 liked rap and rock. Okay, so I find that overlap, rap and rock, which is this yellow and pink almond. 13 total liked it, but I have 9 accounted for. So I'm going to do 13 minus 9, so that means just 4 people liked rap and rock. Total, there were 13, but 9 liked all 3. So then I step out again. 12 liked rap and country. Same idea. So here's rap and country's almond. 12 total should be there. I already have 9. So I subtract those. 12 minus 9 gives me a total of 3. Okay. Take another step out. Notice this is like working backwards because you're really starting at the end and then going back to get the information because you're taking a less specific step out each time. So 19 liked country music. Okay, now I want you to take a look here at this country circle. So here's the green circle. 19 total like country music. But don't I have a lot of people already accounted for? So I have to take the 19 and I have to start subtracting everybody that's already accounted for in country. So minus the 3, minus the 9, minus the 5. That's 18. So 19 minus 18, there's only one person that, did I add that right? It's 17. 19 minus 17 is 2. There's only 2 people. There we go. That's better. There's only 2 people that just like country. They don't like anything else. Okay, let's look at the next piece of information. 24 liked rock music. So within my pink rock circle, I have to have 24 accounted for. So I have 24 minus the 4, minus the 9, minus the 5. I think that gives me 6 left over. So 6 people just like rock. No other type. Rap music, there were 23 people total. So think about what you have accounted for within that yellow rap circle. I have to do 23, and I have to subtract the 3, the 9, and the 4. This is what you do every single time. So that leaves 7 people that just like rap, nothing else. Now the question said, how many of these students did not like any of these types of music? So I'm looking for the neither category. I'm looking for how many people like none, nothing. So what do? This is where you go back to the total. Yep. So I'm going to take 46, which was the total, and I'm going to subtract every single one of these totals within my Venn diagram. So I'm subtracting 7, 4, 6, 3, 9, 5, and 2. That's going to leave me with how many people are within this survey that just didn't like anything. None of these choices. And when you total that all up and subtract it, you end up getting 10. So 10 is our neither category. They fit nothing. And our final answer would be 10 people in terms of our units. Questions on the strategy?